The Arctic shows continuing changes during 2016. Annual average surface air temperature over land was 6.3 degrees Fahrenheit warmer than at the start of the 20th century, warming at twice the rate of the global temperatures. Part of the extreme was due to especially warm air coming from the south during the winter of 2016. Arctic minimum sea ice extent at the end of summer was tied with 2007 for the second lowest amount during the satellite record, starting in 1979, at 33% below the long-term average. The Arctic ice pack remains young and thin and is more vulnerable to summer melting than the thicker, stronger ice pack of the 1980s. With less ice cover, there's more solar heating throughout much of the Arctic Ocean and adjacent seas. As more light penetrates into the ocean photosynthesis increases, resulting in changes at the base of the ocean food chain. The Arctic Ocean is especially prone to ocean acidification due to water temperatures that are colder than those farther south. The short Arctic food chain leaves the marine ecosystem vulnerable to the potential impacts of ocean acidification. Spring snow cover extents continued to decline and set a record low this year in the North American Arctic, driven by warming air temperatures and thinner snow cover during winter. On the Greenland ice sheet, spring air temperatures were warm, setting several records. The melt season started early. The overall trend towards increasing melting continues, as the Greenland ice sheet has lost mass continuously since 2002. Thawing permafrost can release stored organic carbon into the atmosphere as greenhouse gases, and at the same time, increased plant growth stores carbon from the atmosphere. Overall, tundra is presently releasing net carbon into the atmosphere. Small mammals, such as shrews, occupy most Arctic land habitats. They serve as indicators for present and historical environmental variability. Newly acquired parasites of some Arctic shrews show poleward shifts of subarctic species and increases in Arctic biodiversity. In addition to climate change adaptation, rapid, unprecedented rates of change mean that the Arctic today is home to and a cause for a global suite of trillion-dollar impacts, ranging from global trade, increased or impeded access to land and ocean resources, changing ecosystems and fisheries, upheaval in subsistence resources, damage to infrastructure due to fragile coastlines, permafrost melt, and sea level rise, and national security concerns. In summary, new observations indicate that the entire interconnected Arctic environmental system is continuing to be influenced by long-term upward trends in global carbon dioxide and air temperatures, modulated by regional and seasonal natural variability.